Good evening, everyone.
Good evening.
Evening.
Hi everyone.
Hi,
Hi, sir.
sir. Hi, Miss Henningham.
I got that
Yeah,
one.
just
Good evening.
um just waiting for a few more to join. Um uh yeah, we need to see the back of this SB, and we also now need to see how best we can maximize the time we have left in covering some areas. I have a little bit of housekeeping to do in some of the other areas, um, like cost function that I wanted to start that on Saturday. Cost function and some other little small little areas that I need to finish off. But you'll see what is going to happen. What I want to do tonight is to go through what I would call a sorry, a complete question now. Having gone through the SBA, I want to go through a complete question now on regression and correlation to see how it is that you are required to answer it. Normally at the end of it, they will ask you to make a comment. You should know how to do that. You see how I've analyzed the data. So I'm going to give us now 5:33. I'm going to give you about another 5 minutes or so for people to come on. And then I'll start going through that. What I may do is go through, um, I could give you some questions to do. And then I want to, or have you have another group meeting, and I want to come inside of each group. And this is the second half of the class. To have a group meeting, I'm going to come in to each of the groups, and just to see what it is that you have, just to give some kind of explanation to the stuff, for us to do some final fixer upper, and then that should take us up to the end of the class. So I'm just going to need a few more minutes, and then we'll come in. All right, guys, I'm seeing 8 of you. Mrs. Henningham and myself right here. I'm seeing 8 of you. All right, so let us go. I'm going to be sharing a question. And oh no, hold on. I'm going to be sharing this question. All right, let me know if you can see my screen. Can you?
Yes, sir.
All right, good. All right, so it's actually a past paper question. I can't tell you which of the past papers it is, but more than likely, it is a business statistics paper, CCCJ business stats paper that I've extracted this question from. And I'm just going to go through as best as possible. I'm going to also present the solutions as we go along. So it says the number of workers on an assembly line varied due to the level of absenteeism on a given day. In a random sample of production output from several days of work, the following data were obtained. X is representing the number of workers absent, and Y is the number of effects coming from off the line. So it gave you your table of values: 35021, 1621, 812, 9, X and Y respectively. It is asking us to draw a scatter diagram for the data. Now, we didn't do this for the SBA. I'm still in two minds whether or not we should include that. I don't know. But I've spoken to you about scatter plots. We didn't actually do it. But I want you to be able to do a scatter plot in class tonight. And this is what I want you to do for me. You're going to be drawing your X and Y coordinate. This graph is going to be an L graph. You don't have to use the crosshairs because you don't have any negative values. So it's going to be an L graph. L graph, all right? You have only positive values for X, and you also have only positive values for Y. So you're going to be using your L graph. You're going to create, for me, an appropriate axis for X and Y. You're going to correspond your 3 for X to 16 for Y, 5 to 21, 0 to 8, 2 to 16, and 1 to 9. I want you to do that for me because I'll ask different persons, members of the class, to screenshot what it is that they have, so it is that we can look at it. The scatter plot is something that is almost inevitable for them to ask you on the exam. So I'm going to give you 5 minutes to get your L graph in place and start putting on your values. Get that scatter plot for me because we now need to determine the regression line of X and Y. So start for me, please.
Sir, I'm not sure what to do.
You understand what I mean by your L graph?
Yeah. Just plot the data.
Just plot the data. That's exactly plot the data.
Okay.
But remember now, you may or may not have a graph paper. It is good if you have a graph paper, but if you don't have a graph paper, what you need to do is to ensure that your values are equidistant. Everybody has graph paper?
Yes, sir.
Okay, yeah, when you're science students, you man, run it on the graph, let me see it now.
Sir, I don't have any graph paper at the moment.
All right, never mind. What I want you to do is to try as best as possible. Use your centimeter on your ruler and try as best as possible to create, say you have 1, 0, 1, 2, 3, 5. You could possibly say every 2 centimeters represent 1 unit, or every 1 centimeter represent 1 unit. No, you can try 2 to get a good enough graph. So you could use 2 centimeters and use your ruler just to make sure that your points are equidistant. And then for the y-axis now it goes from 8 to 21. You could also go by 2 or 5. Yeah, you could go by 5. You could go by 4 even. You could use 1 centimeter to represent 4 units. You're a science student, so you need to know how to get 9 from that. If you have 4, then we have 8, then you're going to have 12. You should be able to estimate 9 from that. You should also be able to estimate 21 from that when you go to 20 and 24. All right, so do that for me, please. Are you okay, guys?
Yes, sir. Sure.
Ah, cool. I just wanted to make sure that my instructions are clear.
Sir.
Yes, I'm sorry. The screen went.
Yep.
So I'm coming back. I see it now.
Yes, sir.
All right. far are we? Anybody finish it?
Think so.
All right, you think so? All right. Let me see if I can double check. Hold on, hold on. Half a second. What do I do? What do I do?
Finish, sir.
I'm trying to navigate. What do I do? Can you just send me your pics in the group, please, in the group, so I can maybe just project it from here. Send me your plot in the thing. I think that would be the easiest thing. Thank you. All right. You can send them in the group, because I'm just going to pick them out from the group, and we have a conversation on it. So you can send it in the group. You don't have to direct message. Let me see if I can just put this on the computer. All right, keep them coming. I'm seeing them. I'm seeing them. Keep them coming. Keep them coming. Keep them coming. All right. Let's see if I can. Hold on. I'm just recognizing now that I just came into the chat or whatever, and I'm seeing where somebody posted new. Is this a new timetable for the exam?
Yes, sir.
Yes, sir.
I'm only now seeing it. 10% from morning, but I'm only now seeing it. In the interest of time, when is our math exam? May 24th or May 23rd?
23rd.
Oh, so they literally put it down to 3 weeks. When them say 3 weeks, it is literal. 1, 2, 3. Because the exam would have been today, literally 1, 2, 3 weeks. All right. We're giving thanks. Or is it an afternoon exam too? All right, we can do that. All right. All right, I'm seeing. All right, when you look at your plot, how does the points line up to you? Are you seeing any pattern? What is it that you're seeing or not seeing?
It looked like a straight line.
It looks like a straight line.
Sir, it has a little curve at the beginning and then the last point just out of bounds.
All right. Okay, so that's what a scatter plot is. That's what a scatter plot is. I don't want you to do it, but I just want to have a conversation with you. Remember, you know, we are doing this stuff, but I'm also teaching you as we go along. Doing the past paper, but I'm also teaching you as we go along. So yes, the scatter plot is just you putting on the plots on the graph paper. But do you think you can get a line of best fit? Do you think you can get a line of best fit, right?
Yes,
How
sir.
many points will be left? How many points will be left out?
Probably one.
Probably one.
Probably one. Yeah, sir, the one.
Try it.
That's fine.
I want all of you to try it and tell me if it's just 1 point that is left out.
30.
Let's say 2.
2 points? On the same side or on opposite side?
No, sir, 1 above and 1 below.
Mm-hmm. Everybody agrees? I need consensus to know, so talk to me.
For me, I need
Hello?
Sir, for me, the two of them look on the same side.
Or for you, both of them are on the same side. All right. Anybody else? For the exam, I want you to get a clear ruler so that you can actually see through, so you can, because what you're doing, you know, you're estimating the line of best fit. Now, that line that the question didn't ask you to do, but because I'm asking you about it now, what do you think that line is?
Regression line.
Very good. That would be your least squared regression line. That should be your least squared regression line, you know. So just remember now, when they ask you to do a scatter plot or a scatter diagram, it is just you plotting the points, you know, so. But sir, 4 marks to do that? Okay. You get a mark for the axes. And they also give you marks for the plots.
Sir, which one is the regression line?
That the straight line that you're drawing, that you'd have drawn there, would have been your regression line, your line of best fit. Your line of best fit. Do me a favor. I'm tidying everything that we've done. So I'm tidying some geometry with the statistics here. Do me a favor. Each of you, because as I look at the WhatsApp, as I'm looking at the WhatsApp, I'm seeing, okay, for this one, 7297, the first point is a tip out. So those 3 points look like it falls on the line, and the top one is also off. For 0489, it looks the same way, very good. 4268. Yeah, the points look, your points look pretty good, guys. Very good. Yes, miss. Go on, miss. 5511. Yeah, man. Hey, on the bright, you know. Jeez. My students did that. All right, very nice. And even 4519, who is not using a graph paper, I can actually see the pattern that is coming up. Very nice. Very, very, very nice. Okay. So this is what I want you to do for me now. So that's a scatter plot. It didn't ask you to do anything else. It didn't ask you, hence, draw a line of best fit. That's not what the question asks. The question can ask you to draw a line of best fit. Hear what sir is asking you now to do. I am now asking you to draw a line of best fit. The question that the past paper that we're doing never asked us that. It just asked us to do the scatter plot. I am now asking you to do the line of best fit because I'm going to give you something to do for me to see how far or how close you are to it. When you have drawn the line of best fit, I am going to ask you to calculate the equation of that line. And remember, to find the equation of a straight line, I need two things. What two things do I need again? Supposed to know that somebody. A gradient and a
Point.
very good. So to find the equation of a straight line, I need two things. I need a point and a gradient. Now, look at your graph carefully, and you can get your points from it. Let me show you. Let me show you a secret. Let me show you a secret. Are you seeing my screen?
Yes, sir.
All right. Watch me now. And I'm going to show you what I used to do in school. All right. So they asked me to plot the point. They asked me to plot the graph. All right. And I would have plotted the graph. And then of that. So I'm going to find a pair of values. I'm going to either use 316, 512, 08, 212, 19. I just want two of them points. I have 5 points. Remember, your x and y together constitute a point. So I have 1 point, 2 points, 3 points, 4 points, 5 points. I'm selecting any pair of these points. I can select any of the 2 points. I can use 212 and 316, 521, and 19. You will all get the same gradient. I want you to go ahead and calculate the equation of the line for me now. You have a point, you need to calculate the gradient. Is there
Sorry, so we can use any point.
any 2 points? Yeah. Oh, needs to charge. quickly for me, guys, because we need to do some other calculations. Just proving a point. Oh, I should ask you though. Sorry, I should ask you. Are those plots positive or they are negative? Aha. Hmm. Hello?
Yes, sir.
I'm saying to you, are those plots okay? Is your line a positive line or a negative line?
Sir, not sure.
You're not sure. Okay, fair enough. Anybody want to hazard a guess?
Very
Is your line
positive.
Positive, sir.
so okay, so I hear Shante say positive. Shante, why is it positive? How you know it's positive?
Sir, because it's going up.
Very good answer. So when your plots are going upwards, it's a positive plot. If your plots were sloping downwards, and you can know when a plot is sloping downwards. If your plot is sloping downwards, it will be a negative plot. So you know that yours is increasing and not decreasing. All right, it's increasing and not decreasing. All right, continue for me, please. You know what? Let me switch devices. That phone is being-
All right.
Sir, I think I got the answer.
Okay, sorry, I was just trying to disconnect one of the audios. You see, got an answer?
Yes, sir.
Okay, and tell me, what is the, give me the equation of the line.
I have y equals 8 over 3x minus 16.
Y equals 8 over 3x minus 16. All right, thank you. Anybody else? Come on, guys. We did this already, you know. I'm only now trying to link areas that we've already covered. I'm just trying to be creative because the exam can ask you to do this. Anybody
Sir,
else? Yes, yes.
sir, how do I equal 13 over 5?
All right. You have y equals to?
Sir, 13 over 5
Mm-hmm. Mm-hmm.
x plus
Mm-hmm.
b
Huh?
plus b.
I'm not hearing you, honey bunches. Please speak up.
So plus b,
What is b?
so the intercept.
No, if I answer the characteristic equation of the straight line, you know. So I'm
Oh,
asking.
so I calculate the b now.
Yeah?
Sir, I'm calculating it now.
Okay, all right. I'm telling you, you said 8 over 3 x minus 16.
Yes, sir.
Okay. I need to hear the others, please. Hey, I don't want a dead class in tonight, you know. All right. I don't say dead, I say life. Say all una open your mouth and talk, you better talk, you know. But me can go sleep. Sonny boy, open your mouth and talk. Nikki, you know, it's only Mrs. Kenningham alone you talk to, you know. But talk to me tonight. Manisha, I need to hear from you. Natty D, hey Natty. Yeah, we'll follow to know. Terry, open your mouth and talk now. Amelia, talk to teacher. Let me see what the teacher to me. Talk to me now. Nathaniel, will you stay? Is it that you don't know what to do and you don't and that's why you're not answering me? What is the situation? Talk to me now. And if you unmute me, please. Miss Hines,
Yes, sir.
wake it.
For what?
Where sir?
For what, sir?
All right, never mind. You can mute.
Somebody just got this and come back.
Okay.
I never airways.
Jesus, keep me near the cross.
But I don't know if it right.
All right. Tell me to get Buckley. I soon come to you, Nikki. Tell me to get Buckley.
So I'm gonna get 12y equals 4.5x minus 9.
12y.
Sir.
No, I want it in the form y equals mx plus c.
Mm,
Give me the form y equals mx plus c. Johnny, what you get?
So we just have to listen myself.
Manisha, what you get?
So we never do it.
Okay. Natty D, talk to teacher. What you get, honey?
Sir, I got y equal. Wait, sir, wait 1 minute.
Nathaniel, in the meantime, Nathaniel Hall, what did you get, honey?
I'm doing it now.
Go on, then. Oh, I keep tonight. No, man. All right. Whitfield, you do anything yet?
No, sir, I haven't.
The plan is not to keep you late tonight, because I have to go and start reading through the stuff. So I want some quiet time to start reading through and commenting on the SBAs. I set aside a time tonight for that.
Whenever I did feel like calculate out, forget y equals mx plus c.
I don't think my instructions were clear then. All right, let me go again. So what I ask of you is to, having done the scatter plot, I wanted you to create the line of best fit. I wanted you to create the line of best fit. And then now by extension, what I'm asking you to do by extension is to now calculate the equation. So you are putting your line of best fit, and I'm asking you to calculate the equation of that line. Because I'm going to give you something else to do, and we're going to compare those equations.
Yeah, but I did that.
Okay, thank you. So can you give me the equation of the line for what it is that you did?
And that me did give first, and tell me say I want it in a y equals mx plus c, but that me, I don't know.
Yeah, so if you have 12y, just divide through the equation by 12 now, not TD. That now
So
go take you.
divide by 12.
You say 12y, and then me say me want it in the form of equal. So just divide everything through by 12, and bam, you get the answer, and then you can give a teacher. Come on, quickly. Hello.
No, what I get now?
Yes, thanks. All right, so hold on, Javier. 2.67x plus 8. 2.67x plus 8. 2.67x plus 8. 2.67x plus 8. Yeah, tell me what you get now.
Sir, me get y equals 2.5x minus 21.5.
All right. I'll take two more. Somebody was giving me this 13 over 5 something, who was giving me this 13 over? That was you, Natty D?
No, sir.
Somebody had started 13 over 5 and I was typing it here. All right. Give me one more, please. Okay, what were you saying? Tell me again, hon.
Sir, 1 second.
Somebody can still look shaky.
Never mind. Tell me what to get for me.
So y equals 4.5x over 12 minus 0.75.
All right. 2.5x over 12. 2.5 over 12x minus 0.75. All right. Yes, please.
10 to 4.5.
Say it again, Natty.
Not 2.5, sir. 4.5.
Oh, 4.5. Thank you for the correction. I shall correct it. Yes. Kimmy. 4.5.
Y equals 2.6x minus 2.2.
2.6x minus 2.2. Right.
Yes, sir.
And then Natty is saying not 4, sir, not 2, sir, but 4. All right, I'll work with these 5. All right, no problem. Here my instruction now. I want, okay, sorry, not what I want. Let's just go to what the question wants of you. It is asking you, I lost it because I changed devices. So what I want you to do for me now is to calculate the least squared regression. Everybody remember what formula to use to calculate the least squared regression?
No, sir.
You have to commit
I
a
don't
form.
even know what that is.
I'm stop telling lies. Stop telling lies. Stop
All right,
telling
sir.
lies.
Sir, use another word for it then.
Sir, before you go there, it's not 2.2, it's what? So it's 1.32.
This last one is yours, right, Kimmy?
Yes, sir. Yes, sir.
1.32. 1.32, sir?
Yes, sir.
1.32. All right. Me locking in my answers. Me not changing. No. Oh
Sir,
no, it's a wrong place to put it. Jesus, you see, it confused me. 1.32. Give me the other one. 2.6.
Yes, sir.
All right. 2.6x. All right. Locked in. Not change nothing more. All right. Let's go. Tony, you just gave me a joke a while ago. Sir, I do not remember how to calculate the least squared regression. Tan, you play rough. You play rough. All right. Anybody remember how to calculate the least squared regression?
Kinda.
What's the formula? Anybody remember the formula?
Let's see, the sum of n. I think the sum of n times the sum of xy.
Okay, very good. So press pause now. Press pause. What must you first do now?
N.
What must you first do now, class? With the data given, you must now go ahead and do what?
Find x squared and
Find
y
x squared and y squared and xy.
Just say to me, find the sums.
Find the sum.
Very good. So what you now need to do, my document is not opening. I change screen and now this document just decided it's not opening, but you're not hitting the man. You're not hitting the man. It's big business. Yes, so you need to find the sum of all of those now, and then yes, you are going to go with your calculation for B, as you would have done it many times over for the SBA. All right, hold on. Hold on, please.
Sir.
Right. So what it, I'll come and take me. So what it looks like here, Tantan. Your least
Yes, sir. I just Googled it.
Right. Oh, cool. All right. Yes, Kimmy.
Sir, so we should calculate B, R, and
No, you're gonna calculate M, You're going to calculate b, and you're going to put it in the form y equals mx plus b.
Oh.
Yeah, man. So that's how you calculate the least squared regression. So you have to calculate m. So you have to calculate m. You have to calculate b. It's all of 6 marks. You know, so there's a lot of things that I'm going to do. 6 marks for the question I'm giving you here. So you have to calculate m. You have to calculate b and assemble it in the form y equals mx plus b. So what? Remember
All
what?
right,
Remember,
sir. I know what to do.
yeah, that's all. All right. So Kelly, what I want you to do for me is that you need to find the sum of all of those. So you get an XY point for each. You're going to find the sum of x's. You're going to add up all the x's. You're going to add up all the y's. You're going to add up all the x squares. You're going to add up rubbishness. You're going to square the x's and sum them. You're going to do the same thing for your xy. Find all the sum. In order to calculate m, this is the form we're going to be using. N is a number of points, and we have 5 points, I believe. So it's going to be 5 times the sum of xy minus the sum of x times the sum of y over 5 times the sum of x squared minus the sum of x all squares. That gives you m, that gives you b. Let me just pause here
Sir,
to say,
Sir,
sir, is the X and Y values in the table you're going to use for finding, huh?
yes, Johnny.
So, sir, where you use find the Y equal mx plus b?
sir, that's what I did. So, sir, you're gonna have to go back. See, sir, I calculated that already. So you see that 1.32? That is this value right here.
That means you were not. You know,
Yes, sir.
we're not listening. Not sure. All right, never mind, Kimmy. Never
Sir,
mind.
but
No,
I
explain
calculated
it.
a while ago.
Me not
Sir,
explain it. All right, press pause.
Sir, I was
Press pause.
confused.
Press pause. Me not explain it right. Who no not listening? No. Let me tell you what I said, and tell me if it makes a difference with what it is that you did. I am showing you how to do the scatter plot, and about 5 or 6 students, about 5 students sent me, including Miss, sent me the plots. Those plots were perfect. And then I said, I'm going to extrapolate from the question and go into some other stuff just to see if I can tie in things together. I ask you to go ahead, in addition to what the question asks, to do your line of best fit. Understood? Anybody heard that?
Yes, sir.
Yes,
All
sir.
right. Because I want, the exam can ask you to do the line of best fit. So what I want you to do is to do the line so that, as I told you, the line shouldn't have all the values on one side. You should have equal number of values on the top and the bottom of the line. So you're getting your line of best fit. What I ask you to do thereafter is to go ahead and to calculate the equation of that line. So what I expected of you, and maybe I am not clear, but what I expected of you is that you should have drawn your triangle and use your rise over your run in order to calculate the gradient of that line. Because I even went as far as saying to calculate the equation of the line, I need 2 things. I need a point and a gradient. So that's what I expected. Anybody else got anything from what I said right there?
Yes, sir, but I did draw in a triangle.
So yes, sir.
Okay.
So we use a triangle, but we still get that part.
Okay, great.
Sir, however, sir didn't do that. But the B for that would be 8. Well, for me.
And
So
then
for
though,
the 1.32 that you have right there, that is this right here that you're asking to calculate.
and then now, Kimmy, for those of my students who listen well and follow my instructions, I then now wanted you to use this formulation to calculate the equation of the line here, and then we're going to be comparing both equations. The one that you have calculated from your rise over the run and this calculated version.
Okay, sir.
You think it makes sense now, right? Yeah, man. So Johnny, you said that my instructions weren't clear. I don't think I can get clearer than that. My instructions were clear as mud. Yes,
I probably just never understand it good.
possibly, yeah, possibly. All right. So what I want to do is for us to remember I did say that I want to do something different. I want to compare. I want to tie in what it is that we learned previously. I don't know if anybody heard me say that. We want to tie in what we learned previously to what it is that we are now doing. What we learned previously was to calculate the equation of a line. Them here line You just find 2 points on that line. Find 2 points on that line. And I tell you, one of the things that you can do is to look at the values that you have on the stuff, right? So the values that you're looking at in the table, you can correspond those values to the plots that you have, because I'm telling you, your line must go through at least 2 of those points. Whichever two points your line goes through that you've drawn, use those as your A and B. Calculate the gradient, y2 minus y1 over x2 minus x1, and that is going to be equals to m, the gradient. I don't like teaching graphs on the whiteboard because I've been a teacher from the Blackboard days, where I have all my Blackboard geometry set on, which is something I just joking on the Blackboard and can draw my circle nice. The whiteboard business, them use suction, and when I put the suction on the stuff, it just never worked for me, so I just abandoned all of that. So you see Mr. Rookwood have a graph board that we walk up and down with, but that heavy. You understand? The truth of the matter is, I now need to invest in a graph, but I have one. Aha. I have one. My geometry sketchpad. I should be able to do the scatter plot here. All right, hurry up and calculate that for me, please, using the calculations method. Calculate the value of m and b for me. We have been doing all of that for the last week plus. Scatter plot. Construct. Show grid. Okay, you know, I keep forgetting that I spent good money to buy this software, you know. I really keep forgetting. Let me share my screen. I really honestly keep forgetting that I bought this software. And are you see my screen?
Yes, sir.
Yeah. All along when I ask you to plot something, I'm here trying to search something online to do this the plot. And I keep forgetting that I spent some good money to do this, to the point where the company don't even make this anymore. Show grid. All right, give me the coordinates, please. Give me the first coordinate. I'm not looking at the question. What's the first coordinate? Set of coordinates.
X equals 3, y equals 16.
Rockstone. 316. All right, therein lies my problem, because I don't remember how to rescale this graph. Let me see if I pull it. I'll go and, oh, it's an L graph I want now, so I don't need any negative values. Very good. So it's an L graph. I don't need any negative values. So if I do that, I don't need any negative values. 12, 13, 14, 15, 16, all the way up there. So, oh, but I go as far as 21, don't?
Yes, yes, sir.
All right. Label. Show axis. I don't want to label it, I want to show it. What is that? All right. Give me the other one, please. Because I don't remember how to do this.
X equals 5, y equals 21.
X equals 5, y equals 1. All right. Give me the other one, please.
X equals 0, y equals 8.
0 and 8. Give me the other one.
X equals 2, y equals 12.
X equals 2. Y equals 12. Next.
X equals 1, y equals 9.
So those are my values. I can't. Let me see if I. All right.
Sir, why didn't you use Desmos?
Desmos will. Desmos. No, for Desmos, I'm not. I'd have to put in the equation for Desmos. So Desmos, very nice platform, but I'd have to put in the figures. I can't plot.
So you can use the table. They have a table.
You have a table. All
Create.
right. So let me try Desmos then. Let's go and try Desmos. BBS, MOS, Desmos graph. I want to show you. Desmos.
No, sir. Press the add button.
All right. What is X1?
So X values are 3,
Uh-huh.
5.
Uh-huh.
No, X values.
Oh, the X
Not
values
Y
are 3,
values.
5.
Yeah.
Okay, X are 3, 5.
0, 2, and 1.
0.
2
Uh-huh.
and 1.
And 1. What's the Y value then?
16,
Uh-huh.
21,
Uh-huh.
8,
Mm-hmm.
12, and
Mm-hmm.
9. 9.
9. All right. All right. That makes a lot more sense. Let me see if I can get my line. Oh, maybe I want to go Jesus. All right. No. Undo. All right. Mr. Shand. Mr. Shand. Mr. Shand. Mr. Shand. Go again, please, Sanin. 3, 5.
3, 5, 0, 2, 1.
And this is
16, 21, 8, 12, 9.
all right. I was gonna draw the straight line, but never mind. All right, so all right, I'm gonna pinch it to get it. Oh, really? Those 5 are there. I was thinking that there was one more up top. 1, 2, 3, 4, 5. All right, so those are the. Now the truth is, which 3 points lined up for you?
Sir, that was on the line.
Mm-hmm.
0 and 8, 3 and 16, 5 and 21. That's when I draw the best fit line.
All right, so I can see where somebody was saying, because I'm actually superimposing it using something else here now, and I can see where whoever told me that, sir, my 2 dots are on the same side of the graph. Because what it is that you're trying to do is to get as many of the points on the graph itself. Now the 3 middle points The 3 middle points will not be the line of best fit because it does not go over all 3 points at the same time. So you'll have my line of best fit would be 0.2, 0.3, and 0.5. Or 0.1, 0.4, and 0.5. So anyway I look at it, I'm going to have 2 of those points out. So I can use this point, this point, this point, and this point connects on a straight line. What also connects on a straight line will be this point, and that point, right? So you are using a line of best fit. Any 3 other points come on the stuff, you should be good to go, because you can't have, based on what I'm looking at, you're not going to get more than 3 points on the line of best fit, right? But we will know which line is the line of best fit eventually. All right, so this is what I want to show you your scatter plot is going to look like. So if you go into the exam, just do your thing just like this. Get your scatter plot, do your scatter plot. Now I'm going to go back to our information here, and I want you to tell me, have you calculated the line of best fit, the equation of a line y equals mx plus b from these calculations just yet?
Yes, sir.
Yes, sir.
All right, great. Let me go back to my another share. All right. All right, so Tanil, you gave me one of the answers. I think your answer, Tanil, was 8/3 x minus 16.
Yes, sir.
All right. When you did the calculation, what did you get?
For y equals mx plus b, I got y equals 2.8x plus 7.04.
All right, who gave? All right, come, Miss. Oh, Kimoli, this was your actual calculation, right?
Sir, I told you to change the 1.32. Sir, it's supposed to be plus 8.
Plus 8.
Yes, sir.
All right. But this one is for the actual calculation, don't?
Sir, that is for the one that you said to do.
Okay, hold on. So this is, so you have not calculated the m and the b one yet?
Yes, sir, I've calculated it.
Okay, so tell me what you get, honey.
So y equals 6.6x minus 1.32.
6.6x minus 1.32. All right. Who gave me the 2.5? Not to be, you gave me this one. What's your new answer? You gave me 4.5 over 12.
Still a word.
All right, it's still a word. All right. Who gave me the 2.67?
I do.
What you get for your answer now?
So y equals 2.75x plus 7.15.
All right. What it is that I get for this one?
Oh,
Give me
sorry,
this one.
2.76. Y equals 2.76x.
It changes to 2.76?
No, sir, ask me what.
Oh, sorry.
Different.
All right. 2.76, x.
Plus 7.13.
7.16. 7.13. All right. Come not to be. Kimoli, can you check your answer again for me, please?
Okay.
Can you check your B for me again, please? Your M is okay. Check your B for me, Tanya, please.
Sure, that me get to my B too.
Where you get your B?
Sir, my M is
7.0.
okay.
Your B. Oh, your B is 7.0 for sign. Okay. Johnny is suggesting that he got the same answer as you. So what is your equation, Johnny?
Y equal 2.75 x plus 7.04.
Okay. I want to hear from you, Tyree. I want to hear from the rest of you.
So I'm not finished.
Okay. I see Mrs. asking how many decimal places. I see people put in one. I see people put in two. But it's neither here. I normally use a question like this. I will go to two decimal places. 2.75 plus 7.15. Oh, that's JV. All right. Okay, JV, change it to 2.75. Okay, got you. Tariq, what are you saying, Papa?
Sir,
Yes, please.
I said I'm still working, sir.
No. Tell me Tariq say again, please. We're not hearing. Mr. Powers.
Sir, you said you still work.
Oh, that's what he said. Okay, I didn't hear you at all, Tariq. Sorry, I didn't hear you at all. Somebody said, sir, when he was speaking. Who was that?
never mind.
Okay, never mind, JV. All right. Now, I'm a little concerned because I can see this 2.8x, this 2.75, and I can see this 2.676. This one looks a little far off based on the responses given in the class. So remember, the calculation, your least squared regression should all come up. You should all end up with the same answer, because you're using the same set of values. So I'm a little concerned right there. That's why I wanted Kimona to check this one again for me, and I'm waiting on Natty B to tell me what she get for this one.
So I'm going to check it.
Please. Because when you're going to the exam, we are getting the same values. And all right. So for those of you who are not following or not understanding fully what the question is asking, you are given your x values, 5 sets of values, the coordinates 3, x is 3, y 16, 5, 21, 0, 8, 2, 12, and 1, 9. What it is that we're going to be required to do is to sum your x's. So 3 plus 5, 8 plus 2, 10 plus 1, 11. Your y's were given. 16 plus 21 is 37. 37 plus 8 is going to be 45. 45 plus 12 is going to be 57. 57 plus this is going to be 66. My 66 is correct. Look how I get my x squared. 3 times 3 is 9. 5 times 5 is 25. 0 times 0 is 0. 2 times 2 is 4. And 1 times 1 is 1. 16 squares, 256. 21 squares, 441. 8 squares, 64. 12 squares, 144. 9 squares is 81. And I'm summing these to give me 39 and 986 respectively. My xy is multiplied by my 3 by 16 to give me 48. My 5 by 21 to give me 105. My 0 times 8 to give me 0. My 2 times 12 to give me 24. And my 1 times 9 to give me 9. And my sum will be 186. Is there anyone who differs with me with these sums right here?
No, sir, they're good.
All right. So that's the first thing. You must get marks to do that. Not ask you. Must get marks. Now remember my M formulation. Remember my M formulation? You must know the formula. The formula you must know. Don't expect them to come and give you a list of formulation on the exam paper. You may not get it. And it will be sad to know that you understand the topic, but you just don't know the formulation for it. So therefore you need to lose the marks. And it's plenty enough marks, So CCCJ give you out of 20 marks for this question, and this is a full question from CCCJ. Then sir, so long the question said, no man, I explain as we go along. Let's go. So it says n, which is a number of terms, and we know we have 5 terms, and you're going to be multiplying that by the sum of xy. The sum of xy is my 186. Normally when I look at this, this is my x, my y, my x squared, my y squared, my sum of xy. So it's going to be n, which is 5, times my sum of xy, which is 186, minus the sum of x times the sum of y. My x is here, my y is here, so it's 11 times 66. See it right here, so? And I'm doing this so that when you put your stuff into the thing, at least you can see the pattern. Your x, your y, your x squared, your y squared, and your xy. Just do it in sequence. It's going to be n times this minus this times this all over n times the other 2 that you never did use. Or, well, when you're calculating the least regression, remember we don't need y squared. Anybody remember that?
Yes.
Yes, sir.
Right. So you don't need y squared when you're doing your least squared regression. But when you're using the correlation coefficient, no, y squared becomes important. So that's why we calculate y squared here. Remember, the least squared regression, we don't use y squared. So look at what is happening now. So it's going to be n times this minus this times n times the other one that we never use, which is going to be 39 minus the sum of x, all squares, right? So the sum of x is going to be the same thing here. So you just have to look at the pattern. Look at the pattern. The pattern will help you to understand and remember the formulation.
Sir?
Go ahead, honey.
Sir, I rechecked.
And?
Sir, I made an error with the.
I'm going to beat you. I'm going to beat you. All right, tell me the correction now.
Sir, y equal 2.76 minus 7 plus 7.1. Sorry.
All right. Okay. Natty B, you finish it, honey?
No, sir.
All right. All right, no problem. No, this I can work with. No, that I can.
I is finished. I have y equals 2.76 minus, wait, Jesus Christ, 7.08, well, plus 7.08.
Okay, so you got 7.08. All right, so you have 7.08. Tanin has 7.04. All right, fine, fair enough. Fair enough. All right, fair enough. I can work with that. Let me go back to my share, please. I'm much more comfortable with what is happening here. You see, why I decided to do something like this in class tonight, I don't want a facade, because we worked on the SB and we know to do the calculations that you're not able to see the questions as questions because you saw the questions as SBA. So I no need to translate it, so it is that you're able to see how the questions are asked. Because remember, best believe you have to go do some interpretation, just like how sir interpret something, you have to go do some interpretation. They may give you a mark, a 2 mark, up to 5 marks for interpretation. All right. Now, so we're gonna have 5 times 186 with 930, and you work with all of this stuff here, and you get a 2.7568. Now I can see where Penny got her 2.8 because she round up to 1 decimal place, right? So I ain't gonna kill you for that one. All of you, some gave me the 2.76. Most of you gave me the 2.76. Let me see if I can just go back. 2.76. Somebody gave me 2.75. So the person who gave me 2.75, you did not round off properly. All right.
Stop, whenever.
Say it again, JB.
I just stop at 2.75 whenever I look at them.
Yeah, so so you have to look to make sure that you do the proper round off. All right. So it's just me. I'm not cussing you out today. It's just me trying to put the icing on the cake now. Literally, just putting the icing on the cake now, so that you can understand what is happening. I can understand 10 is 2.8 because you round up to just 1 decimal place, right? Now let me just explain what is happening. So Miss put in the chat, Mr. Shan, indicate please if it is that you're using 2 decimal places or 1 decimal place. All right, let me just explain what happens. Because I also mark for CXC, all right? I don't do it for the money, and that's just the honest truth. I do it because I want to become a better teacher. If I'm teaching with an external body, I need to know how the external body, what it is that they are looking for. It makes me become a better teacher, and especially when I'm teaching, so I can tell you what it is that they're looking for. Now, if the question says, giving your answers to 2 decimal places, it means that if you give them to 1 or 3, you're going to be penalized. But if the question is not specific to say how many decimal places, I normally leave my answers 2 decimal places when I'm doing a question like this. So in a case where Tanil now went ahead and round up to 2.8 as opposed to be using 2.76. What the chief examiner will say to the markers is, if you see 2.8, award a mark. 2.76, award a mark. All right. Now, what they may say is, if you see 2.75, do not award a mark, because they would expect at this stage that the students should know that they need to round up. Real talk. So that's why I want you to do what it is that I'm asking you to do, so that I can inform you what it is. So because I didn't specifically say to use 2 decimal places, if a student used 1 decimal place, if the question was not specific, and the student used 1 decimal place, the examiners will not penalize the student. All right. However, if the student is rounding off and did not round off correctly, they would lose that mark. So that 2.75, they may penalize you for that one. And I'm just telling you, no, better make the mistake now than going to the exam and make the mistake. All right. So the Lord still strong, JV. So just be careful on that. So I'm happy for that one. I'm really happy for that one. All right. My B now, I get 17 point rubbishness. I get 7.134. I get 7.14. Let me just go back. Tanil, go ahead again. John Mark, you did say that you support what Tanil gets. All right. Let me just explain the difference now, because I'm seeing 7.1. Kimoli, give me another decimal place for that one, please. You said 7.1. 7.1 what?
7.13.
7.13. 7.15. All right. Oh, okay. Johnny, you got 2.
It would be 7.14.
7.14. Okay. Johnny, you got 2.8 for your M also, like Tanil?
No, sir. But when I did the B, I did use 2.8, and afterward I did take it.
All right. Okay, that explains it. All right. So, and this is why it's important now, guys. Let me just explain something now. So, if somebody went ahead and calculate B using the 2.8, they may end up with the 7.04. All right. So, so this is why I'm saying I normally use 2 decimal places, as many decimal places as possible. You may see me write 4 here. So I put my 4 decimal places here. What happens? If I use anything less than these 4, these values going to change. So I may end up with the 7.04 here, right? So I'm saying this to say to you now. So in the case where the examiner say, if you use 2.8 a watermark, it means that the value of B is going to also change. The value of B will also change from 7.15 or 7.14 to possibly 7.04. All right. So she would not be penalized there either. Right. So if they give them and hear me out. And if they don't double penalize you for the CXC exam, right? So if they penalize you for an error up top of the question, but you use the error correctly throughout the question, they will award you the mark for the other parts of the question, even though it is still incorrect enough, but they mark for their methodology. So let me say that one more time. So you get a question for 5 marks. But you ended up substituting the wrong value into the function. They will penalize you for that, -1 mark. But the value that you get out of that, the output value that you get from the substitution of that incorrect value, they will give you a mark, and they call it FT, follow through, right? Sometimes you see Mrs. Thomas write on your paper CE, consequential error, right? So like for you're marking your titration and something, they penalize you for your titer value. Your titer value is off a little bit, but you can get full marks for your calculation because we penalize you for the titer value. But if you use the incorrect titer value in the questions to come in a correct fashion, you get all the marks associated with those questions, but they will penalize your job. What's the point I'm making? For a question for 20 marks, for argument's sake, you can come out with 19 marks or 18 marks, depending on the amount of marks that the penalty will attract, right? So I'm just saying to you, just be consistent with what it is that you're doing with your calculations, all right? Be consistent. And let me just say this one last time. So it's when it is that we're using, when it is that we're doing our statistical calculations, I don't want you to just go and use one decimal place. Use more than one. You can use 2, you can use 3, you can use 4. But don't use just one because it will throw some values off. That 7.4 is way too low compared to the 7.13 that most of us were getting. All right, so with that said, I'm just explaining. It's better for us to make the errors now than going to the exam to make the errors. I'm proud of you though. Proud of you. With a little nudge. Let me just do this finally before I continue with the question. All right. So you recognize that most of you, well, this person and this person may have been the closest with our B values, because I end up getting some negative values here that was not or should not be a part of the calculation. Getting some negative values that really shouldn't be part of the calculation. So this 8/3 is 2.67, which is the same thing here. Okay, 2.6, I guess that there. 4.5 divided by 12 is 0.375. So this value is off.
Okay.
Yes, honey.
Actually,
Actually, what?
one minute actually draw, a proper line of base with the equal amount of points. On the same side, for B, would I get 7.2?
Very good. Very nice.
Yeah.
Very nice. Very nice. All right. So I wanted to compare based on your line of basis and give you a rationale for what is happening here now. When you're doing, and this is why statistics is really not bad, because it can see through the calculations. What is happening here is that you notice the variations of the questions, the answers that we get, because everybody's line of sight is going to be different. Me wear glasses is definitely going to be different. All right. So when you're calculating your regression, that's why I would never normally use the line of best fit and calculate the equation of that line to use, because there are going to be variations to the value of your B. Your constant there for you to use in this stuff is there's going to be a gradient, there's going to be a difference. So we go ahead and use a calculations method. Now the calculations method is more precise, which is why this piece out here, I'm very happy that you guys are getting it, because this piece is more precise. Now, when you're doing your statistical calculations, not everybody's going to come up with the same answer. You should come up with the same answer for your summation, right? But if you are consistent to say, you know what, I'm gonna use 3 decimal places. Say I say to the class, go ahead, don't use less than 3 decimal places. 3 decimal places, right? You do your calculations to 3 decimal places, all of you should come up with the same answer. But for me, I normally, because I know exactly how important these decimal places are, right? I will go to 4 in my calculation. This one I went up to 5, right? But importantly, never use 1 decimal place, right? Use 2, 3, and if you're stretching it, you can go to 4. All right. Okay, let's go now. So I am now assembling it into the equation. So this is what I end up getting, my least squared equation. That's what I get in. The question said, use the equation to predict the number of defects. Use the question. Use the equation to predict the number of defects you would expect on a day where the number of absences was 4. Watch me now. Remember it says X is the number of workers absent. So in the equation, X, the X here is going to be 4. So I'm going to substitute 4 in there. So I'm getting 18.162442. Should I? How many persons you expect to be absent? You can't say 18 because it's more than 18. So you're going to round up. You can't have 0.16 of a person. So you or a defective item, you're going to have 19. So we would expect 19 defective items. If you put 18, you're going to be off. They're going to penalize you because your calculation came out to be more than 18. 18 point something. So you have to round up and call 19, right? So it's just like when you're doing a calculation, you can't say 18.16 persons. It has to be 19 persons. I keep saying to students, there's no way. I went to Sugar and Spice today. I had a crave and I decided I'm going to go to Sugar and Spice today. And when I looked at the cakes, not the cupcakes, but sometimes when people don't pick up them cake and just slice it up and sell it so you can buy a slice of birthday cake. Yeah. So when I look into the tray, I'm seeing a lot of crumbs. I mean, there wasn't a full cube as I cut it in. So I'm saying, but then suppose me if I go buy this now. Then if I go get one box and crepe out the one of that and put another something because that is not a full slice, right? So I think the last person who is going to get it will have to get this up. What's the point? You have to be very precise because I keep saying to people, I'm not going to go to a store and buy a plantain tart that was beaten into. You want a whole tart? That's what I'm paying for. I'm not going to go to the store and buy a shirt and that's I don't understand you ladies and gentlemen of this era to go and buy a pair of jeans where it appears as if you and a dog were having a friendly encounter because the front of the pants tear up, the back of the pants tear up, or even sometimes a piece of the fabric is left and you guys, females, are wearing the rider of the posterior. No, sir. If you buy a jeans, you buy one full jeans. You don't want no tear up. You understand? So that's exactly back down wear it. I hear you. Right. Okay. So it's going to be 19. So this is a part of the explanation. If you say 18, 6 is going to say mark it wrong. You have to understand the concept that you're talking about. Items that are being sold. Is it being sold? Assembly line due to the level of abstinence. Yeah, man, the number of workers, right? So the number of items coming in from the defective line, right? So it has to be 19. All right, look at this last piece here. We're supposed to calculate what it says. Calculate the correlation coefficient R and the coefficient of determination. No, sir. But you never tell me about coefficient of determination. Okay, fine. You never did that for the SPA, so that's why. Let's go. No, I shouldn't ask you to. Let's go. Let me project that. Go ahead and calculate the correlation coefficient for me, please. Go ahead, calculate the correlation coefficient for me, please. I'm explaining this, because I'm going to give you one and give you about 10 minutes to do it on your own, fully. And nobody's going to know who I'm calling upon to do it. Because I know some people here now who with nothing. Jesus, redeem them, Lord. All right, I'm muting. I'm going to refresh myself and come back. Please calculate the correlation coefficient R for the data. You have the data already. Substitute it, please, and thanks. Finish? Anybody?
Yes, sir, finish.
Okay, right. You're waiting. Good. What you got for the answer?
0.9.
0.99.
0.99 is correct. Now, 0.99. I need somebody to interpret that for me, please.
Positive.
I hear something.
Positive correlation strong.
Okay, so positive correlation strong. So what I would say is there is a very strong positive correlation between, and this is how we're going to put it in sentence form now, between the number of workers absent and the number of defects coming from off the line. Because remember, you know, when you're doing the correlation coefficient, you're actually comparing two variables, your x and y. So you don't need to define what your x is. Your x is the number of workers absent, and y is going to be the number of defects coming from off the line, right? So these are very strong positive correlation between those workers that are absent and the defects coming from the line. 2 marks for them, something there. All right, and then now we talk about the coefficient of determination. My r squared, my coefficient of determination, when I square that, I'm going to get 0.98. So that is going to be the coefficient of determination right there. Oh, see right here, there is a very strong positive correlation between absenteeism and the number of defected items produced. The coefficient of determination is like you saying a percent. This is 0.98. I can say 98%. Can you see that 0.98 is 98%?
Yes, sir.
Right. So the coefficient of determination is if I want to represent my data in percentage form. So like when we did our calculation, we got something like 6.09 for the correlation of something. Don't remember what, but I can remember we got a 6 point something. We can do the coefficient of determination, and we can when we square the value of r, that will give us as 2 decimal places that we can represent it as a percentage in that regard. All right. So any questions? That's the end of the question. The 5 mark is a 5-part question. Sorry. Let me tell you how many marks they gave for this question. 6 and 4, 10 and 2, 12 and 3, 15 and 1, 16 and 2, 18. This is an 18 marker. 6 and 4, 10 and 3, 15, 16, 17, 18 marker. Are there any questions? All right.
No, sir.
No, sir.
So I have a question, sir.
Go ahead, Papa.
So in the exam, if they give you to calculate the correlation and regression, that is the R, you have to do over the entire calculation.
For what?
To find R. Like at for the first part of it, it is basically N, it's asking for. I just put back that answer.
Yeah. Come on, you have to do the because if you do the calculation under the same calculation, I will go over again.
Yes, sir. That's
You just speak up, man. You just speak up from where you are. All right, 9 and 7, 16 and 2, 18 and 2, 20 plus 5, 25. So this is a 25 marker. They may not give you a 25 marker in the exam. What I suspect may happen is that, and I'm hoping that you'll get a question on this topic for between 10 and 20 marks. They can give you a 20-mark question, or they may give you a 2-part question, this carrying 12, 13, 14 marks, and another question for the remaining marks. I'm going to give you 7:30. I'm going to give you 10 minutes to and check in on you after those 10 minutes to see how far you reach. I'm going to ask you to start now for me, please. Hear me out.
Yeah.
Be very careful with your table of values. Double check it. No use no phone, because I can't use no phone in the exam. Use a calculator and check this up and make sure you get it right. Yes, please, go ahead.
Never mind.
All right, thank you. Start, please. You know what? In the interest of time, let us have a conversation about part one of the question. In the interest of time, it says state the independent and the dependent variable. Which is the independent variable and why? Which is the dependent variable and why? I knew it.
Third.
Me would have said acres burned would have be X and then fires would have be Y.
Okay,
Yes, sir. I was thinking the same thing too.
Okay, so you're saying fires will be Y, and you're thinking
And
acres
X.
and acres
So the
X.
dependent is fire and the independent is acres burned.
The dependent is, okay, the dependent is fires, and the acres would be the independent.
Yes, sir.
As the fire, you know, yeah.
Okay. Anybody else? Guys, I cannot be in a class teaching and I'm asking you to try and explain something and you're
the independent would be the fires and the dependent would be the acres burned. Because if there's no fire, there's acres wouldn't be burned.
Thank you, Nikki.
Yes, sir, I agree with that one.
Yeah, I agree with Aniki.
Okay. Anybody else agrees with Aniki?
Yes.
Yes, sir. Yes, sir.
Yes, sir.
All right. All right. So very good, Aniki. So the independent variable. So if there is no fire, then there is no acres. So the number of acres burned will be dependent upon the number of fires. True or false?
True.
True.
So the independent variable will be fires. And that now depends on the dependent variable is going to be acres. Let me just put it in a different line. Y equals 2x plus 5. My x is my independent variable. The woman them do what they want to do. And then now y cannot move until x tells y to move. So when x is 0, y has one value. But when x goes to a different value, y has to move in tandem with x. So my x is my independent variable. X goes wherever x wants. And then the output is going to be my dependent variable. So the input is my independent variable and my output is my dependent variable. So y is going to be my dependent variable. Y depends on x to tell me what y value is. You follow what I'm saying? So is there anybody in the class that is not seeing what is happening? So if there is no fire, there is no acre at all that will be burned. So acre is going to be, the acres burned will be dependent upon the fires. So my fire is going to be my independent variable and my x is going to be the dependent variable. All right. Now that you know what is x and what is y, put your x down, put your y down, and this goes for everything else. All right. Start, please. Obviously.
So doing number 3.
All right, cool. Anybody finish?
No, sir.
Finish?
No, sir.
Sir,
No, sir, soon.
Finish now?
2 more minutes.
Okay. All right, guys, can we go now? Matthew, are you finished?
Sir, I am finished.
You're finished. Okay, thank you, Tatiana. Johnny, finished?
Finished.
Kinda, sir.
Kind of. Kimmy, how is it? Shanti, did you answer me? Finish for me?
Yes, sir. Finished.
Nice. Natty
Yes,
B,
sir.
how is nice? Natty B, how is it? All right, no answer. All right, what did you get? All right, so we did the first part. Your scatter diagram. I should think that you will know how to do that. Find the equation of the least squared regression line. What's the equation of the least squared regression line? What did you get? Kimmy, what is that?
Sir, I have y equal 1.17
What equals what?
1.17x.
All right, let us check. Let us start with this first. Did you get these as your sum?
Yes, sir.
Okay. And y is equal to 1 point what?
1.1680.
Yes, sir.
Oh,
That's what I got.
fabulous. Fabulous. And what is B? Sorry, Kimmy, what you saying?
So why you make it seem like I was wrong?
Did I tell you that you were wrong?
Sir, but
Kimmy, we need to tell you you're wrong. We need to tell you you're wrong. Kimmy. What do you get for B? Tell me what you get for B.
sir, minus 10.69.
10.69? 10.69 or 10.6? All right. So, for the most part, you got it. Very nice. Is there anyone in the class that did not get that least squared regression line?
Yes, sir.
All right. Where did you go wrong?
The sums
The sum.
for y squared and x times y.
Oh, you didn't get 1705?
Nope.
Strange.
0.69, sir, because I round up to 1.17.
1.17. Okay. All right. That's fine. Oh, you got negative 10.69. Yeah. So when you use less decimal places, you're going to get a little bit more like what we found in the other one. All right, Tani, waiting on you to double check for me, please.
Sir, can I see what? Sir, can I see a y for the? Oh, sir, I know I did wrong.
Okay. All right. I'm happy you recognize. Is there anyone else that didn't get it? Honesty is the best policy, you know. Don't sit down there and go like you understand something and then you go into exam and bam, 20 marks and you lose 20 marks because you don't understand. Yes, Johnny, what you saying, Papa?
I have the wrong thing for x squared. Sums.
Okay. All right. Let me tell you what. And again, some of what it is that you're going through, I would have gone through myself. I thought I could have moved very fast on my calculator. I mean, add up and get myself and move on without double checking my things. You see this table here? Do your calculation first, go back and double check your calculation. Ensuring that you clear your calculator so that no answer is stored in it. And if you're not too sure, turn your calculator off and turn it back on. you have to be very careful with your sums. If your summations are incorrect, trust me. If the methodology is right, as I explained to you earlier, you still pick up marks for not being get 0 out of the number of things.
Sir, I had 15 instead of 5 for Y.
Oh, okay. Where under the 14 you had 15.
Yeah.
Okay, got you. Yeah, so I'm gonna ask. I'm happy that the mistakes are being made now. I'm gonna ask that you try as best as possible not to make those grave errors. All right. Okay. What's the value of R? For those of you who never made the error, what's the value of R?
0.0796.
Oh, sorry. 0.0796. Let me just check that.
No, sir, 0.796.
To the T. To the T, Nikibo. To the T. It's so life is over when you don't get up and go to foolishness. And you sit down and get the work done up. Nice. Very nice. To the T. Right down to the last decimal. Don't leave a crumbs in the plate. Craven. Not a crumb in the plate. Very nice. All right, there's another part of the question. It says, predict the number of acres that will burn if the number of fires is 26. So in my least squared regression, I'm going to substitute. Remember, X is the fires that is burn. You know, this question kind of give away this. If you never understood the first part, by the time I reach this part here, you will figure out which is the independent variable and the dependent variable. Because there's something inside here, so is independent, and this one depends on what this value is so that you can work it out to get this value. All right. So if you never got the first part right, by the time you reach right here, hopefully you'll kind of figure it out.
Sir.
Yes, honey, go ahead, please.
What was the answer for R?
0.796. You got that?
Yes, sir.
All right, next. Let me just go back and explain here though. It asks you how many acres will burn when 26 fires. Predict the number of acres that will burn if the number of fires is 26. I got 19.713. All right. Then, sir, you can have 19.713 acres burned. Yeah, I can. But you see, the question asked me a whole number here, so 26. You notice inside that here, so there's no decimal. No decimal. So when me go give people in decimal. 28, 19, 30, this, 13, 7, 14, 7, that. Me not give them no decimal. Man, they never give them no decimal in the question. So me round up. And I tell the man, them say, yo, 20 acres of burning. 20 acres. Some students, funny story. I have, oh, that student from that long time, that one 2, that one 3, that one 4. I can think of at least 4 students of mine that are firefighters. One of them is assistant superintendent. One of the assistant superintendents, big shot people in the force, in the brigade. I would have taught her this in one of the courses, math courses that I taught her. Here, what is happening? She's sitting at her desk and she said, you know what? In this pandemic, we have a lot of house fires. And she's able, to record and get the data. And she can say the cause of the fire was this, whatever the situation is. She can sit and she can calculate her regression that information now becomes very useful to her department. And let me just explain this. Let me not even go outside of another example, but just to use this one. I'm saying to you that 20 acres of fire will burn. All right, 20 acres of fire will burn. Let me go back to the question. Yes, honey.
Sir, I'm not getting the answer.
You're not getting the answer? What you're not getting? What are you not getting? Not getting the which one?
M.
Which one you miss? M. Your these totals don't correspond to my total.
Oh, I know what.
Okay,
I
all right.
changed the value to 5, but I never add over the Y column.
Okay. All right. Where is I going? All right. So look at what is happening here now. So the number of acres burned is 25. 25 acres will be burned. The question says, what did the question say? No, question is up top. Predict the number of acres that will burn if the number of fires is 26. And one may say, but sir, 28 burn 19 acres and 24 burn 25 acres. So why 26 is going to burn? No, yeah, 20 acres. It is what the calculation gave, because 24 also burned 20. But based on the calculation, 26 is going to burn 20 acres. Irrespective of what the data looks like, let me tell you how important this is. As a fire chief, if I were the fire chief and I do this calculation, I'm looking at my data and I'm going to say, okay, my maximum amount here is 25. I must make sure that as a fire chief, I have enough water to put out 25 acres of fire. I must have either water or some carbonate or dry ice or support from a neighboring fire department with helicopters. And I'm going to look around to say, all right, within this district, because I'm the fire chief of this thing, within this district here, the plant, I have 20 houses that have swimming pool. If me run out of water, I'm going on them swimming pool, take out the water out the fire. These are all the things that you need to do to look for your resources, right? Because if indeed you have a fire and you don't have the resources there, the city is going to burn flat. So this is how important the data is. This is how important for you to calculate the data and to interpret your data. Very important. Does that make any sense to you?
Yes, sir.
So my R to be 0.796. My coefficient of determination here works out to be 63%. All right, so the likelihood of that happening is 63%. So there's a strong positive relationship at 7.8, 7.96, which is 0.80 between the number of fires and the number of acres burned. So it is very important that we from this information we can extrapolate to put things in place, as I told you before, the resources, XYZ, because they can answer questions like this in the exam, and I expect them to answer questions like this in the exam for you to analyze and set your data. All right. Now, are there any questions? I mean, I have another question, but I won't do it to you tonight. But are there any? Well, I have just one other question. Just one other question that teacher has. That topic here finishing now. No, no, one other question. Two other questions. This topic here finishing now. 2 questions. This topic is finished now. Let me ask you, are there any questions?
No, sir.
No, sir.
All right. So before we go, my plan for the night didn't work out as I wanted it to. But before we go, in terms of going through, showing you 1 or 2 other stuff, I needed to show you some stuff. Let me see if I can project something here. All right, so I'm just going to show you the layout of something. So some years ago, a couple of years ago, about, I think this was 2020, just when we went into the pandemic, I was teaching art math. And, one of the things, because again, I normally teach a science group, I always find something scientific to work with. So we're looking at the volumetric and sugar content analysis of iCool flavored drink. All right. Now, remember I talk about the table of contents and the list of tables. So I'm showing you the layout. All right. So once you're doing an SBA with me, must have a table of contents. Then you're going to have your list of tables, all right, and figures. Of course, you're going to have your acknowledgement, you're going to have your title, and all of these, you see, the acknowledgement is on 1 page. So not because I have more space here, I'm going to do the stuff. My title now is to be on a page by itself. We're looking at a mathematical investigation of the volumetric and sugar content analysis of iCool flavored drink. This was pretty interesting. It wants a teacher go to a supermarket, go pick up different flavors of iCool. But the good thing about it is that we could have drinking them afterwards. So we just poured a little bit in a volumetric flask, and then we got a refractometer. So now there is a background, right? So in Jamaica, we don't have a lot of documentation of branding. Like these food manufacturing companies don't have much information on their website. They don't have a website to get information. So for example, if you want to get information about First Caribbean or NCB or BNS, chances are you go on their website and you're not going to get anything about the history per se. All right. So we had a challenge in getting some of the data, but nevertheless, we need to have the background. Why is it that you're doing that? All right. So we had a background here. Then we have the purpose of the study. Why are you doing the study? The purpose of the study is to investigate if Glasses claim regarding the sugar content and the volume of 6 assorted 330 ml iCool flavor compared with what is on the product label. So we're comparing what them say is contained in another drink to see if it is true. And what we did was to use a refractometer, and that refractometer actually tests the sugar content. So I could just pour a bit of the sugary drink into the refractometer, and the refractometer will give me a reading. Now that reading will give me the Brix reading, which is the sugar content reading, right? And then we had to do some calculation in order to come up with our stuff. And you will see what's happening here. All right. It is aimed to the volumetric analysis. I sorted that. Just in the background was really because at that time they were talking about the sugary drink, level of sugary content in drink, and the schools should really have more healthy food stuff now in the cafeterias. And those persons who are selling in and around the school community should also sell healthy stuff for students because, talk about the rates of high blood pressure, diabetes, support, and so on, etc., etc. You buy your fries and you dose it with whole heap of salt on it, and you eat that every day. So your salt content, your sodium content is continuing to increase on a daily basis, and after a while, it just pops. Your sugar contents continue to increase on a daily, and after a while, your poor little system just getting in the plan. Bam, can't bother more. Insulin not be producing no more, and you have to go take false insulin and radiate it, and the whole works. Right? So that was the background of all of what was happening and the purpose of the study. Right? What we did when I went to purchase a drink, I recognized that I had one with reduced sugar and one with regular amounts of sugar. So I said, it is nice if we can do a comparative test. So of course, teach about an assorted flavor, set of things, some with reduced sugar, and some with the regular stuff. All right. And we total, it was a whole case that we purchased. We look at our methodology. This is what we use: a retort stand, measuring cylinder, distilled water, filter funnel, dropper, cleaning wipes, and the refractometer. In addition, a case of product that contained 24 pieces of bottle of assorted alcohol flavored drink. Right? The chosen case included 6 assorted flavors and a list of flavors. And we spoke about how it is that we're preparing the stuff. So I'm talking about the methodology, how it is that we're going to do, just like what you write in your method for your chemistry lab and your physics lab and the bio lab. We talk about the methodology here. And then the presentation of the data was very important. So we had 4 bottles of reduced lye. Why did I have it? I don't remember. This was from quite a while. Don't remember why oh, yeah. So we had 4 different flavors of reduced sugar and many other flavors of regular sugar. So for the reduced sugar, we had melon berry. Don't ask me why. Fruit punch. Can't remember what it is that we did. I don't remember what it is that we did here. We tested the volume. It's supposed to contain 330. We tested the volume. We got 335, 35. This one was a little bit more. Then we get a little bit more strawberry, banana. This one, them did us very exactly a little grape, not a little more, not even a little drop more. They come out of the bottle. This one, the fruit punch, they did kind of nuffish or something, bust to gas to. The tangerine one was a little bit less than the 330 that they told us that it's going to contain, right? So they kind of rub it in another one here. And then now, when we do this stuff, we spoke about having a range, because when them say it's 330, it is a range of values. Say, yeah, right. We buy 330, we want 330 or more. All right. The sugar content, the Brix reading is what it is that we use a refractometer, and we got that. And we convert it to get the sugar content. The temperature of the drink at the time is very important, because you know that from chemistry that temperature increases the rate of a reaction. True or false?
True.
Yeah, man.
True.
Yeah, man. So what happened now is that we had to go ahead and ensure that the temperature of the drink in question was at room temperature, pretty much, right? That wanted to kind of look like, yeah, we didn't know, yeah, that wanted to kind of look offish, little bitish, And per 240 milliliters per serving size, we got all of those. So, and of course, my table must have a little thing about it. I can't just put the table without putting a label. And we did our graph. The students were very creative, the fruit punch, them get the try and get the colors to match what is happening. So we have this one here is both reduced sugar and regular sugar, reduced sugar, regular sugar. So we had 4 of them, as you see up top here, with reduced sugar, and enough more with regular sugar. So this one here was reduced sugar. One of them reduced sugar, regular sugar, reduced sugar, regular sugar, so forth and so on. So we had 4 with the reduced sugar, regular sugar. So we did this sort of comparison here. So this is a comparative test with this one. This one was also a comparative test, this one and this one. We recognize that this fruit punch here, the one here, was really an anomaly. One of the things I can tell you off the bat, just looking at this here now, is that the filler machine may have malfunctioned at that point in time and just spit out. Sometimes there is, like when you turn on your pipe at home and there's air in it, something and just, splash out. I hate going into the bathroom at school and I'm washing my hands. And 2 things that I hate: washing my hands, and stupid enough, and I still don't learn. I go in the soap dispenser and I soap up my hands first, and then trying to wash off. And many times over, there's no water in the tap. So what teacher have to do now is to go and take napkin and dry the soap off his hands. It is the most annoying thing ever. And the second most annoying thing is when I go into the bathroom to wash my hands and there's air in the pipe and it go and spit out and wet up the whole of the front of my pants as if I had an accident when I went into the bathroom. So I'll be standing in the bathroom to say, okay, when are you going to dry? I can't take off my clothes in the bathroom to dry it on the hand dryer because somebody may come into the bathroom. So I'm there walking briskly back to the office to sit down for quite a while to let it dry, right? So it's like that. I'm thinking you could have, for example, the bottle being filled up and there's air in the pipe and it was spit out or spit too much of it and then you can have that. So this is just an anomaly at that point in time. It could be many or varied reasons, but we don't know which is which. And then we did our stuff. Of course, we had to do some stem and leaf also. We did our stuff or write up, and we spoke about it. We did our mean, mode, median. We did our box and whisker. We had our conversations, analyzing the data. And we kind of rocks them a little bit, one of them, if I remember, one of the things right, so the reduced sugar as per label nutritional fats indicate that 9.2 grams percentage sucrose pound solid per 240 milliliter serving data shows that a mean of 10.02 grams of sugar. This would equate to 9.6 grams of sugar per 240 milliliter serving. This suggests that the flavored drinks contain more sugar than is advertised. So based on what it is that we did for the experiment, right here in the chemistry lab, we found out that it contained more sugar. And I think there was another thing. There's another, it's like we talk about the Food and Drug Administration regulation requires that. We need to look at some stuff because as Miss says that we could do in terms of our teachers. So it is that we can have some, not only what we say, but what other people say in the stuff. Right. And there's something else in the study that I think, don't quote me on it, based on what it is that we did, that the reduced sugar don't contain as much reduced sugar as them claims it contain, right? Or box and biscuit came out to be that. And we had a limitation. The data indicated that the filling machine was well calibrated at 335. The slight variation could be as a result of leakage from the source to merchant during transportation. The sample size was also considered to be extremely small. Right? Suggestion for future work. Remember, you have to put your suggestion for future work. The research design could be repeated using a much larger sample size for each flavor, just like Uno. The research design could be repeated using much more data from the pre-SBA, right? The total number of flavors manufactured by the company should be included in the sample. This is important to investigate, especially the sugar content that differs from the advertised based on the findings of this research. All right. And conclusion can be concluded that the company prides itself on its result-oriented approach and its passion to satisfy their customers. The volume and sugar content were found to be consistent as advertised on the product label. It was perceived from the taste that the sugar content. And that's another thing that we did. We did a taste test, and we also did the test using the refractometer. Taste test is also, well, in this case, it was very important because what we did, we covered the faces of the students and asked them to taste the stuff. Each group member was asked to taste the sugary the one regular sugar versus the one with reduced sugar, and for them to say which one tasted sweeter than the other. And we recorded that, so we were able to get some data from that also. Based on the serving size, it was calculated that the flavored drink contained more sugar than indicated on the product label. This could be attributed to extremely small sample size used in the experiment, right? So we have to do that, and of course we did our references. You can use online references, information extractors. I told them when I extracted this data. So if I go back on their website and it has changed, sure, say the 20th of January 2020, this is what I got from the system. And pretty much that was the SBA. Now, think of this. This is additional math. So what was required for the additional math, of course, is definitely not going to be required for the CAPE, for at the CAPE level, right? But it's just a layout I want you to see what is happening. I'll show you what point I was trying to bring across with us here. So you have your acknowledgement, you have your title, you have the background, the purpose of the study, your methodology, you're going to present your data, you're going to have a discussion, right? And you don't have to follow this slavery because you already have it in and it's slightly different from what your CAPE outline that you all have would have said, but you need to go through and order your information in a similar fashion. That's what I was trying to do today. And of course, I got distracted by many things. So I didn't get the chance to do all of that. But I am a little sleepy, going to get a nap, get up and finalize the stuff. I am also in receipt of some of the SBAs. Thanks for being very compliant. And I am going to go through those, make my comments, and then we need to fine tune. We're going to give you back those. I will send you a copy of what it is that we have done. Miss and I had a conversation, and in this stuff, Miss already did the calculations using the pie charts. So what I'm going to be doing is using a different method of analysis, looking at the percentages, and then maybe just make a few comments on the interpretation on the the pie chart in terms of percentages. And I did that based on what it is that we look back at on the SBA, talking about percentages, etc., etc. So as soon as I get through the scanning of the SBAs, I'll send you a copy of what it is that I have. Remember, I'm sending you a copy of what it is that we have, not for you to take verbatim from it, but to use it as a guide to get your stuff. There are 5 different groups, 5 or 6 different groups, 6 different groups. And each group should have, we're using the same data. We're not changing, the data can't change. We're using the same data. Calculations will come out to be the same. But our explanation and interpretation may vary somewhat. Or it is that we word it will also vary. But the essence of what it is that we're talking about will be there. And that's why we are together, Mrs. Cunningham and myself together, putting the information so you can have it as a guide. So thanks for those who submitted. I think the last time I counted, I saw 4. I will go through those that I've seen. Those of you who don't submit, it's not a problem. It's when you submit the final stuff, when we're ready for mark, you're not going to have an opportunity to get any feedback to go and fix up, right? So I'm going to give feedback. Hopefully tomorrow's Tuesday. I hope I don't have a meeting tomorrow. I'm hoping that tomorrow I can spend about a good 3-4 hours in the morning half, and just get these SBAs out of the way so I can give you some feedback. But thanks again. It was important for me tonight to go through some calculation regression. I have some other stuff to do with you, some little fillers. But I also needed to just get through some things out of the way. All right, I'm going to end right here. Tanil, I need to speak with you when class ends. Tanil, I'm going to ask you to give me a quick call, please, hon. I need to talk to you about an email that you sent me. Are there any other questions?
No, sir.
All right, cool, thanks. Tatiana, I spoke with my colleague. When was award ceremony? Whichever day was award ceremony, I spoke to my colleague and asked him to bail me out. And the truth of the matter is, I'm still waiting on him. That's the honest truth. I'm going to touch my base with him again and ask him to just fix those videos for me. And I can send them on. I apologize for the delay. This clearly is about me. Me to study the sciences. We never do computing. Not even do computer physics. Matter of fact, in my time, CC never had information technology. And if anyone of you call me old, remember that I'm still a teacher here. But yeah. All right. Any other questions? If no other questions, remember to say a gentle Jesus and just continue working on the stuff. And we will meet up again on Friday. I will give you, those of you who came on Saturday, I have not yet marked those. The little pop quiz that I gave you, but I'll definitely mark and respond to your Dropbox. So you see the email once it gets back into your Dropbox, and then we can just fine tune some stuff. Thanks again for coming out on Saturday. Thanks again for being my students. Have a wonderful night. Can you call me, please? Later.
Yes, sir. Bye, sir.
Yes,
Bye,
sir.
sir.
Bye-bye.
Bye.
Bye-bye. Bye-bye, dears.